Hi, I'm Sarah, and today we're going to be learning about work and force and power. To start off with, what is work? Well, work equation, which can be found in your reference table, W equals FD, is equal to force, which the work is applied, and the displacement of this force on the object. Work is measured in newtons times meters, as the newtons is for the force and the meters is for the displacement. Work is a scalar quantity and therefore does not depend on direction. Direction would be based on a vector quantity. If work is measured in newtons times meters, we can say that work is measured in joules. And the equation for work, force times distance, is found in your physics reference table. So let's do a practice problem for work. Say we have a 300 kilogram car pulled across 475 meters in 400 seconds by a force of 40 newtons. What is the work? Well, to find work, we use our equation, force times distance. We look to see what we're given. We have the force of 40 newtons times the distance displacement of 475 meters. So we do 40 times 475. And we remember that we are measuring in joules for units, and we come out to say that work is equal to 19,000 joules for this specific problem. You can also find work using force due to gravity. If we remember, force due to gravity is equal to mass times the gravity acceleration constant, which we know is 9.81, we could say that if we had a 6 kilogram car and you do work by lifting it, how much work can you perform in a 150 meter distance? We can again find work, force times displacement, through the 6 times 9.81, which is equal to 58.86, which will be for the force in the distance of 150. To become equal to 8,829 joules total. Next, let's look at power. Power, by definition, is the rate at which you do work. Power is equal to work divided by time, or since we know work is equal to force times displacement, force displacement divided by time. Power is measured in watts, as it is joules over seconds. So let's do a practice problem to understand how we can calculate for power. So let's use what we had in our last example, the 6 kilogram car, lifted 150 meters, but let's say now in 20 seconds. We want to find the power. Well, again, we need to find first the work, which is equal to the force times the distance. We said the 6 times the 9.81 times 150. And in joules, This again will get us 8,829 joules divided by the time, which we are given 20 seconds, to find the power. The power is equal to 441.45 measured in watts. And that's how we would find the power if we were given the mass times the acceleration constant times the displacement over which the force is applied and the time. Now, energy can either be potential energy, which we can represent by PE, or kinetic energy, KE. Potential energy is stored. Kinetic energy is energy in motion. The equations for both of these, which can be found in your physics reference table, potential energy equals mgh for the height, and kinetic energy equals 1/2 mv for velocity squared. The conservation of energy states that energy cannot be created nor destroyed. So let's do a practice problem to figure out how would we solve for potential energy or kinetic energy. Say we have a truck that has a kinetic energy, it's given, of 9 times 10 to the 4th joules. When traveling, the velocity is given 15 meters per second. We want to know what is the truck's mass. Well, we can recall that kinetic energy is equal to 1/2 mass velocity squared. Kinetic energy of 9 times 10 to the 4th joules is equal to 1/2 the mass we are looking for times velocity, 15 squared. So we know that 15 squared is equal to 225 times 1/2, 112.5 times the mass is equal to 9 times 10 to the 4th. Well, when we divide times 112.5, we can assume that the mass of the truck is equal to 800 kilograms. Let's do a problem where we are solving for potential energy. Potential energy, as we remember, is mass times acceleration due to gravity times height. Say we have a potential energy. Say we have a mass of 500 kilograms of a truck, and it's risen 15 meters above the ground, therefore the height is equal to 15. We need to find the potential energy. So mass, 500 we plug in, times 9.81 meters per second, times the height of 15 meters, and we can say that the potential energy is equal to 73,575 joules.